So let's go through your review. Remember, this review is for you. Make sure you're answering the questions. Make sure you're understanding what it's asking. Just the basic. Distribute, collect terms, solve for x. Is there any domain restriction in this equation? Nothing to worry about. Number 2, is there a domain restriction here? Yeah, let's work out your domain restrictions. You have two radicals. So they're not under a fraction, so I'm just going to set them greater than or equal to 0. So this one says subtract 3 and divide by 2. This one says add 2. Now, on your number line, here's your negative 3/2. Here's your 2. So for this whole problem, what is our domain? So if I put a negative 3/2 in here, will that work?
No.
Okay, so if I use a negative 1 in here, will that work? If I use a 0 in there? So 2, it's where they overlap. 2 to infinity. Can this one use a 2? Yep. Can this one use a 2? Yep. This one cannot use a 0, cannot use a 1. So I can't use any of this part for this whole equation. So this is my domain. God bless you. Now, radicals to solve, isolate your radicals. That means get your radicals each to one side with equal sign. If you FOIL this, you end up with 2 different radicals in the middle, and you're going to have to isolate them, and it's going to be a mess all over again. So isolate either one of these to that side. When you square both sides, don't forget to FOIL that out. You have to distribute that out. It's a binomial. This pops out. Once you get here, that's fine. You can lose those parentheses. Collect your like terms. Isolate your radical again. If at this step it is possible to divide by a -4 evenly, then divide by a -4. If not, square both sides. Don't forget to square that as well and distribute it. You have descending variables. Starts with the 2 exponent and it goes down. Get it to one side, factor. Get your roots and don't forget to check. In this case, even though they're part of your domain, neither one of them work. They're called extraneous roots. If you reject both, then it's a no solution. Good? All right, and an absolute value equality, remember, draw yourself a simple one. Think of an easy one. This could be a +3, this can be a -3. So you're going to have 2 branches. One equal to the +3, one equal to the negative of whatever's on that side. And just make sure your absolute value is isolated first, and then just pull it out. So this is isolated. Give me the positive, give me the negative. Solve both, and don't forget to check. And doesn't always mean that a negative will not work. In this case, I cannot put a negative on that side, right? So anything with a negative in this case will not work. Because an absolute value cannot be equal to a negative number. So right away, I can get rid of my negatives. I don't even have to check that side. So stop me if you have any questions. Here's your absolute value inequalities. So you're going to get everything to one side. Oh, sorry. This is your quadratic inequality, your rationals. Sorry. And it gives you an absolute value inequality. I didn't give you an absolute value inequality. All right. So here's a quadratic. Get everything to one side. try to keep the 0 on the right side. Find your critical values on your number line. These are your zeros. Set it equal to 0. Find your zeros. Test your intervals. There's more than this for an answer because you have an inequality. So test your intervals. Again, this quadratic opens up. It's positive. So superimpose that right on there. These are where all your x's are positive. Your y's are positive, your y's are negative, your y's are positive. Your value of your inequality or your equation is the y value. And we only care if it's positive or negative. And then give me a solution. If I wanted it less than 0, I'd be looking for the inside, the and. A rational expression in here means already by itself, it's already one term. We take the zeros of the numerator, zeros of the denominator are these guys. And the zeros of the numerator. Put them on your number line. And if it helps, so you're going to have to go to your calculator anyway, it makes life easier than plugging the values in. Go to your calc, put it in your y1, and test your intervals. In this case, you wanted the negatives. Okay, remember, this denominator has a problem here. So it cannot be 0. So the 5, whatever's in this denominator, in the case of this 3, has to be open. The 5 is your numerator. The 5 can be whatever this one says. In this case, it's also open. Your denominator is always going to be open. Your numerator depends on if you have an equal sign in your inequality. Did you get this one? No 6. There was no 6. It was on a different page?
It was on the same page as 7.
Did you get this one on yours?
Yeah.
Okay. I added this, so I probably stuck it in the wrong spot. I added this because I didn't have one of these on yours. So remember when we did this? We said set this up on a number line. There's your endpoints. This is an and statement, so it's going to give you some kind of less than. It doesn't have a hard bracket, so it's just a plain old less than, no equal to, right? Because it's an and statement. It's like this. It's an and. An or would be two things with an or in the middle. That'd be a greater. So that one that comes together is an and statement. So map it out. It's easier to look at this way when you look at your number line. Find the midpoint, add the two endpoints, divide by 2, and it certainly makes sense. Now, find the distance from either endpoint. In this case, the negatives are easier to look at. So the distance is 5 here, the difference. And that always has to be positive. Set it up. When it comes to x minus a negative 3, x minus a negative 3 gives you x plus 3. Then test it. Test your final answer. Yes?
How do you know when you have the less than or greater than?
So an and, this is an and. When it goes like this, that's a less than. If this is a hard bracket with two numbers in here, then it's a less than or equal to. An or, we'll do this. We'll do something to something or something to something. That's a great, misspell it. That's a great or. This is the easiest way to remember it. Misspell your greater than with an or. There's your or statement. That's a greater than sign. Yes.
So if it's an or statement and then like if it's a hard bracket and a soft bracket?
It won't be. It'll be one. Both will be hard or both will be soft. It won't be. In other words, if I change this and I say, right, let's make one. Negative infinity to negative 3. Or 5 to infinity. Okay, so there's my or statement, right? Put this on a number line. Find me the midpoint. Add them together. Divide by 2. What's your midpoint? 1. My midpoint is 1. What's the distance, the difference from here to here? 4. So x minus the midpoint. And here's my difference. And now here's my inequality. But because I used a hard bracket, this has an equal sign. A great or is my or statement. So x minus my midpoint greater than or equal to 4. A great or is an or statement. This is an and. Okay, it just keeps everything right in here. Okay. I probably stuck this number in the wrong place. Oh, there's 6. There's 6. Okay, so another rational inequality, get it to one side, find yourself a common denominator, do not cross multiply this guy, do not get rid of your denominator. Always do a domain restriction first. If you eliminate your denominator, you eliminated those 2 restrictions. Graph this when you get this. Remember, graph this in your y1, graph this in your y2. Make sure they are the same graph. Then you know you did everything right. If you graph the original one in your y1, and you by chance cross-multiplied and got rid of your denominator, when you graph that in your y2, it's going to be a nice little smooth function. It's not going to have any asymptotes in it. You'll see right away that you did something wrong. Get used to looking at the graphs of these. It really makes a big difference. Find your common denominator, convert your numerators, keep your denominator, take your zeros of your numerator, zeros of your denominator, and test. Okay. Remember, if there's a single term here, say I do 3 plus this, don't forget you have to convert that one as well to make everything one term. It has to be over one term before you can do your zeros. Okay. Here's a nice little equality. When you have an equation, you can absolutely just multiply and get rid of your denominator because you have an equal sign. Find your domain restriction. I don't think I asked you to, but just in case, jump over the 2, go from 2 to 3, jump over the 3 to infinity. Solve. And if this was something that I wasn't allowed to use, then I would have no solution. So if you do your domain restriction first, it kind of helps you when you get down here to your answer. Number 8, if it was factorable, then factor. This one wasn't, so quadratic formula.
Would it be okay if you just did 1/3 square root of 3? I mean,
Yeah, that's fine too. You just separated the denominator, that's fine too. However you want to reduce it is fine with me. Even if you probably left it like that, I would probably be okay with it. Yes.
wait, so how come you got rid of the denominator first then?
Because this has an equal sign. So in this case, you can get rid of your denominator. An expression, you can't. An expression, so that rational little thing over there had an inequality, not an equal sign. So we just dealt with the rational expression part of it and put it over the same denominator. This one has an equal sign, we can get rid of everybody's denominator.
What is that only on top over the x equals minus 6
This, I just factored out a 2. If you just separated it here, this is fine too. As long as you somehow reduce this. So if you gave me this, I'm fine with that. And I don't even care. You probably could even leave it like this. I'd be fine with that one. But this one has to get reduced. And it doesn't matter if you separate them or you factor out, whichever one you're comfortable with. I tend to factor out. And I tend to leave it like this, but you can also do this. Good? Everybody good with this?
Yeah.
This nice little juicy radical one was last. Again, isolate your radical. I don't care if you move the 2x to the other side. If you, whichever one you move, I usually move the tougher one. Just so that in case anybody did that one, that's where usually more mistakes are. When you do this, be careful of this guy. You have to square 2. This is a monomial, so you're squaring the 2 as well as that radical. So it comes out to be 4x. This one you have to multiply out. Then isolate this middle term. Get everything else to one side. At this point, if you wanted to divide by 2, could you very easily divide by 2 here? Very easily divide by 2. So if you took this guy, and you divided everybody by 2, make your life a little easier. And square both sides and solve from there. I would only divide if everything comes out nicely. If you end up with a fraction, you square the other side.
I did that, but like, the answer that I got
Was different?
yeah.
So move everything to the other side. So factor out an x. So x is equal to 0, x is equal to 4. Okay? The 4 didn't work? Okay, let's check. Another good way to do this is put it in your calculator. You can put this in your y1, you can put this in your y2, and see if it crossed at the 4. That's another nice way to check. You can move everything to one side and check that way. Let's put a 4 in here. So the square root of 4 is 2, so 2 times 2 is 4. 4 times 2 is 8 plus 1 is 9. Square root of 9 is 3. Yep, this one goes. And if you put this in your calculator, I'm a big check on the calculator person. You'll kind of see that. I like to check on the calculator. If you put this on one side of your equal sign, I don't know if you guys got used to doing this. So put this on one side and then put the 1 on the other side. And then put the 1 here. Where they cross has to be your solution. So look for where they cross. And it's going to only touch it once, and it's going to cross at the 4. See it? It's a nice way to check. See it, Mommy? It's a nice way to check your answer. I mean, this one wasn't too bad, but... Are we okay with this?
Yeah.
All right.